So mass spectrometer and ionization energy exercise, which is related to unit 1. We have already completed this topic. You can use the chat to state the answer. I will discuss each question. For any question, if you want to answer, you can use the chat to state the answer. Which element is in the D block of the periodic table? So actually, the whole periodic table is divided into blocks. The first two group are the S block element. Then group 3 to group 8 are P block element. Then between group 2 and 3, we have D block, and then we have below bottom of the periodic table, we'll have the F block elements. The whole periodic table is actually divided into blocks. So group 1 and 2, S block. Group 3 to group 8, P block. Between them, the D block elements, and then we have the lanthanoids or actinoids or the series. So this is a division of the whole periodic table. So we have S, P, D, and F. Now in the question, they're asking which element is in the D block of the periodic table: argon, chlorine, iron, sodium. So when you check the periodic table, so you will find Fe or iron is there. So argon is P block element, chlorine is P block, iron is D block, and sodium is S block element. So the correct answer for this one is D. Sorry, C, not D. It's a D block element. Option C is the right answer. Then, what is the equation for the third ionization? Like energy needed to remove the third electron. So we already remove 2 and we have to remove the third. So here, these two are totally wrong. Why this one is wrong? Because we should not remove all the electrons together. And why this is wrong? Because ionization energy means energy needed to remove electrons from a gaseous state. So we should have a gaseous state, not solid. So when we check option C and D, why D is wrong? Because here it is in a solid state, but it cannot be in a solid state. It should be in a gaseous. So already 2 electrons are removed and we are removing the third electron. That's why C is the right option for this. Then question 3, the first 3 ionization energies of the carbon are shown. What is the approximate 4th ionization? So best way to understand the ionization, you should write the electronic configuration. So carbon is 6 and 12. So it is 1s2, 2s2, 2p2. So we remove the first electron because total 6 electrons are there. So we remove the first electron from 2p. So this electron is removed from 2p. Then this electron also removed from 2p. Then we remove from 2s. So another also we are removing from 2s. So we are removing from the same orbit, same subshell. So if we are removing the electron from the same orbital or same subshell, that time there should not be a big jump. So option C and D are showing a big jump like 11,000 and 38,000. So there it means totally wrong. And when we remove the electron, ionization energy increases. Like first ionization energy is lower, then second ionization energy will be higher than the first, then third will be higher than the second, and so on. So ionization energy should always increase for a consecutive removal of consecutive electrons which we remove from an element. So it cannot be A as well. So what we are left with? We are left with option B. Is it clear?
Yes.
Then in question 4, the chart shows the first ionization energy of elements from fluorine to magnesium. So what is the approximate? Remember the general trend, ionization energy across a period, that's the general trend, it should increase. But what we find that there will be a difference between group 2 and 3. Group 2 ionization energy will be more than group 3, and group 5 and 6 also will find a difference. The 5 ionization energy will be more than 6. Rest all follow the sequence, but only 2 differences are there. So here this is fluorine, which is a group 7 element. After fluorine, when you check the periodic table, here the periodic table. So after fluorine, we'll have neon. So this one is for neon. Group 8 element and occupy the peak. Then after neon, we'll move to another period. Like this is period 1, period 2. Neon and fluorine are period 2. Now we move to period 3. And ionization energy, as we move like down, for changing the period, the ionization energy decreases because the electrons are far away from the nucleus. So means the ionization energy of a lithium will be, or beryllium will be lower than the period 2 elements. So this will be group 1, then group 2, then moving from group 2 to group 3. Generally, this is a general trend that ionization energy increases, but there are 2 contradictions. One is between group 2 and 3, another one is group 5 and 6. So what should be the ionization energy? So group 2 is there, like this is sodium, which is group 1, then we have magnesium and then aluminum. So where the ionization of aluminum will lie, it will not be above 2, it will be below 2. So it will be between magnesium and aluminum, sodium and magnesium. So this will be the first ionization energy of aluminum. Why it is not higher, as we already discussed, like when I write the electronic configuration for magnesium, it is 1s2, 2s2, 2p6, 3s2. And for aluminum, it is 1s2, 2s2, 2p6, 3s2, 3p1. So aluminum is having more inertial electrons, so greater shielding effect as compared to magnesium. That's why for aluminum, we need a smaller amount of energy. So it should be between 500, this is 500 and this is 750. So it should be between 500 and 750. So which number is there between 500 and 750? That is option B. So 600 is the right answer. Is it clear, this one?
Yes.
What about you, Taha?
Yes, sir. Clear.
If it's not, just let me know, so I will repeat. And you can use the chat for any question you want to solve. You can use the chat, just state the answer. In question 5, the decrease in first ionization energy down a group in the periodic table is caused by increasing in. So as we go down the group, like as we move down to any group, we find the ionization energy decreases. So what could be a reason for that? Why there's a decrease in ionization energy as we are moving down the group? So lithium, sodium, potassium, rubidium, cesium, francium. But as we go down in this series, in this group, we find that the ionization energy decreases. So what is increasing that causes a decrease in ionization energy? So when we check the options, the force of attraction between the nucleus and outer electron, it does not increase, it decreases, because that's why the ionization energy is decreasing. If the force was increasing, then the ionization energy should also increase. The number of neutron in the nucleus, so the number of the neutron in the nucleus as we go down the group, that is increasing, but that is not responsible for decrease in ionization. This is true, this statement is true, but that is not responsible for decreasing the ionization energy. The number of the proton in the nucleus, that increases, but if the number of the proton increases, the ionization energy should increase. But that this is decreasing, so mean that is not the this statement is true that the number of the proton and the neutron are increasing as we go down the group, but that is not responsible for decreasing the ionization energy. So why the ionization energy decreased? Because the shielding of the outer electron from the nuclear charge. So D is the right answer. Like lithium will have 2 shells, sodium will have 3 shells, potassium will have 4 shells, and all have the same number of electrons in the last shell or outer shell. This will have 1 electron, this will have 1 electron, this also have 1. For lithium, inner shell few electron. For sodium, more inner shell electron. For potassium, greater number of inner shell electrons. So the shielding effect is increasing, and that increase in the shielding effect causes a decrease in ionization energy. Is it clear? Discussion 5.
Yes.
Yes.
Then the structure question is there in between, like this file is having a mixture of structure and MCQs, like some structure question, then MCQs, and a pattern repeated. So you can have an idea of overall idea how the structure questions are there as well as the MCQs. So this question is about the atomic structure in the gases. Chlorine exists as 2 isotopes, which is having a 35 and 37. State the number and the type of each particle in the nucleus of chlorine 35. So only they're asking for nucleus. Nucleus does not contain electron. So when you check the periodic table, you'll find the chlorine is 17. So if chlorine is 17, it means it will have 17 protons. And 17 minus 35, so it will be 18 neutron. They only ask in the nucleus, that's why we don't have to mention anything about electron. If you mention about electron, you will not score a mark. Then complete the electronic configuration for a chloride ion. So chlorine atom is having 17 electrons because chlorine atom is a neutral. So 17 proton or 17 electron. But there's a chloride ion, so it will have 17 proton, but it will have 18 electron because it gained electron. So we have to arrange 18 electron or write the electronic configuration for 18. 1s2, then 2s2. So we have to write the electronic configuration for 18. So 1s2 is there, 2s2, 2p6, 3s2, and then 18 are there, so 3p6. So this is the electronic configuration of the chloride ion. Then a sample of a chlorine contains 75.53% of chlorine 35. Calculate the relative atomic mass of a sample to 2 decimal place. So one is 35. So if 35 chlorine 35 is 75.53, then remaining of the sample will be 37. So 100 minus 75.53 will get the remaining of chlorine, which is 37. So chlorine 17 and 35 with a percentage of 75.53. Now how we get the percentage of a chlorine 37? We subtract from 100 75.50. So we'll get as 75.53 there. So we'll subtract from 100, we'll get the percentage of chlorine 37, which is 24.47. Now to get the average mass of the 2 isotopes, so percentage of the isotope, which is 75.53, multiplied by the mass of the isotope, so percentage multiplied by mass of the isotope, which is 35, plus the percentage, it is 24.47, multiplied by the mass, which is 37, divided by 100. If the ratio or fraction was given, then it will be divided by the sum of the fractions. But here the percentage is given, that's why we divide by 100. So when we solve, it will give us 35.49 atomic mass unit, or you can say U or AMA. Write your final answer in two decimal places. When you're mentioning the final answer, it should be in two decimal places. In question 7, this question is about the phosphorus and some of its compound. The atomic number of the phosphorus is 15. Complete the electronic configuration of phosphorus atom using electron in a box model. Look, here they mention Ne and E. So means till neon, the number of electron or electronic configuration is same. So what is the electronic configuration of neon? Like neon is having 10 total. So 10 electrons are already arranged till neon. We have to arrange 15, so we have to arrange 5 more. So how we arrange? 3s will have two, one clockwise, another one anti-clockwise, because opposite spin, so they can overcome the repulsion. Then 3p, when electrons occupy, first they will occupy singly and then they will pair up. But first it's always single. Explain why the first ionization of phosphorus is greater than sulfur. So best way to, as we already discussed, like either there will be a difference between 2 and 3, or there will be a difference between 5 and 6. So why phosphorus ionization energy is more than sulfur? So when you write the electronic configuration of phosphorus, it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s, 15 are there, sorry, 1s2, 2s2, 2p6, 3s2, and 3p3. So the electrons are occupying singly. But for sulfur, 16 total number of electrons. So 1s2, 2s2, 2p6, 3s2, and 3p4. So in case of when I only draw the 3p orbital, 3p subshell, so electrons occupy this first, they will occupy single and then it will start to pair up. And due to this pair up, the repulsion between the electrons will be more and greater repulsion, so it will be easy to remove electron. So writing the electronic configuration here, only drawing 3p. So for sulfur first singly and then there will be a pair. So there's one pair present, so more repulsion. But here what happened? They all occupy singly. As a result, they will have a weaker repulsion. So the answer for this question, it's important that you learn the structure of the answer. Like you should understand like what points you should include. So first you can mention phosphorus is having a half-filled subshell, and due to this half-filled subshell, they have a small or a minimum repulsion between the electrons. Whereas, sorry, phosphorus is having a half-filled subshells. As a result, we need a smaller amount of or half-filled are there, less repulsion, so we need more force or more energy, as their unpaired electrons are there. But in case of sulfur, the outer shell electrons which are there, both have the same shielding effect. But because there is a pair of electron, and due to the pair of electron, there is more repulsion. And as this repulsion, we can easily remove the electron out from the atom. Is it clear why the first ionization energy of phosphorus greater than sulfur? 2 marks. So one is for a pair of electrons, so unpaired electrons in phosphorus, and there are paired electrons in sulfur, so they will have more repulsion. It will be easy to remove electron, or a smaller amount of energy can remove electron. Is it clear?
Yes, sir.
Yes.
Then the phosphorus has a high melting point, which is phosphorus has about 44, and phosphorus has a melting point of 44, where silicon is 1410. It's not a high. Explain why melting temperature of phosphorus is lower than of silicon. 3 marks. So this is related to bonding. First thing, because in case of a sulfur, when we check the sulfur, it will have a simple covalent structure. Like first is in terms of structure, then in terms of bonding, and then in terms of force. So phosphorus, it is having a simple molecular structure. Where silicon is having a giant structure. Then both have covalent bonds because these are non-metals and non-metals have a covalent bond. And then we need a greater amount of phosphorus is having weak force between the molecules. It is known as the van der Waals force. Here in case of silicon, they have a strong covalent bond. The bond between the atoms are strong covalent. And due to this strong covalent bond, what will happen? This will be like need more energy to break the bond. Here we need less energy to break the bond. These are the points which we should include when you are comparing the melting point of different elements. Compare the type of structure, compare the strength of the force between the particles, like type and strength. And then the one which is having a lower melting or a boiling point means it is having a weaker force between the particles. Is it clear?
Yes, sir. But why phosphorus is having molecules? Why not
Phosphorus
atoms?
is forming 3 bonds. So forming a 3 bond does not support the giant structure. As silicon can form tetrahedral structure, so tetrahedral structure can be supported, like the tetrahedral bond are there, like the structure is tetrahedral, which can support the giant structure. But for phosphorus, 3 bonds are there, so it's not able to have a very long chain compound. But silicon, like carbon, silicon, they can form 4 bonds, more bonds per atom it can form. As a result,